Hi everyone, Mrs. Basega here, and today we're looking at a simulation where we're looking at different types of collisions. The collision you see here is an explosion. When Damon and Christine push on each other, the force interaction between the two of them causes both of them to change momentum. So my goal in this video is to help you calculate momentum from a video. First, let's picture Christine and Damon. Initially, they're both at rest. The simulation tells us both of their masses is 60 and 66.5 respectively, and therefore we know the initial momentum of the whole system is 0. But what if we need to calculate the final momentum? Well, in order to do that, you need to be able to measure velocity. Since Damon is moving to the right, let's start by measuring his velocity first. First, we're going to adjust the video just to where the two stop exerting forces on each other. I'm going to rewind back to where their hands are just letting go of each other. That looks good. And that's going to be my start point. From here, I need to place a ruler where I can see the motion clearly. In this case, I'm going to place a ruler right at Damon's toes. Click the ruler button on the right for the right object and move it up to its known starting point. Now that we have the distance origin set, we're going to set the time origin, or set the time for the start of motion. So reset the timer to 0. Do this by clicking the timer button and clicking reset. Now distance and time are both set to 0. Next, fast forward the video several moments. In this case, I forwarded it to the end of the frame. Use that to then measure displacement. He moved 40 centimeters, and time, 3.33 seconds. Finally, use those two together to calculate velocity. In this case, he moved 0.4 meters to the right in 0.333 seconds. Dividing those out, that means Damon moved 1.2 meters per second to the right. Together with that mass, I can calculate his final momentum. So now all I need to do is go back with Christine and repeat the same things. So I reset everything back to the beginning of the video, moved my ruler, the timer's already set. I fast forward to the end, and now I'm going to measure displacement and time. In this case, I'm going to zoom in to see her displacement. Christine moved 44 centimeters backwards in the same 0.33 second increment of time. So when I go calculate her velocity, I should end up with a negative because she moved left. Her velocity is negative 1.32 meters per second, giving her a final momentum of negative 79.2 Newton seconds. Finally, at the end, you're asked about something called conservation. Does the momentum before equal the momentum after? In order to answer this question, you're going to need to measure the total momentum for, which in this case was 0, compared to the total momentum after, which was positive 0.6 Newton seconds. Depending on how you decide to argue this, you could say this collision may or may not have obeyed the law of conservation of momentum. So give it a try with your collisions and see how you fare. Best of luck!